Okay, YouTube, this is my first video in a module that I'm doing on solving exponential and logarithmic equations. And so the first thing we do want to do is confront what the heck we mean by an exponential equation. So of course, let's review that an exponential equation is any equation containing a variable in the exponent. So that would be something like these that you see here, where we have some base that is a positive constant that's not equal to 1 and some variable in its exponent. So oftentimes we want to solve for these values that are located in the exponent, and so it makes it a little bit difficult to do unless we learn a few techniques to do it. So in terms of learning a few techniques to do this, one really convenient way to solve exponential equations, kind of like this one right here. This is 2 to the power of 3x minus 8 equals 16. I recognize that 16 is a power of 2. But if I were to rewrite that here as 2 to the 4th instead, one really convenient way to solve exponential equations is to rewrite both sides so that they have the same bases. And the reason why is because if I were to tell you that 2 to the power of this is equal to 2 to the power of 4, because these were equal to begin with, then this 3x minus 8, that would have to equal 4. And then this would be something we could certainly go and solve. If I add 8 to my 4, I get 12. And if I divide this by 3, I suppose I would get a 4 here. So the idea is, can we rewrite both sides having the same basis if we want to solve an exponential equation? So we say that the one-to-one property of equality for exponential equations is expressed thusly, but if b, which is some base, expressed to the power of m is equal to b also, but to the power of n, then it can be concluded that their exponents must be equal, and we'll refer to that as our one-to-one property. So if b to the m equals b to the n, then we can set the exponents equal to each other and solve for the variable. So as we look at these equations here, you're often going to see equations where we have some exponential thing here. And our first question is, can we solve using one-to-one property? That's the question we're trying to answer. And we can here. The reason why is because this base here and this base here, they're both powers of 5. That is to say, I can say that this is 5 to the power of 3x minus 6, and that the right side, I could rewrite this as 5 to the power of 3. And so because of our one-to-one property, we have two bases that are equal to each other, then we have our exponents are equal. So we'd say 3x minus 6 equals 3. And that's just what we've done right here is the second step. Set the exponents equal to each other. So adding the 6 to both sides here, certainly get a 9 on the right side, so 3x equals 9. And dividing everything by 3, we get x is 3. And we can definitely check this. If you plug it back in, we get 5 to the 3 times 3 minus 6 power equals 125, and 3 times 3 is 9, and 9 minus 6, of course, is 3. So 5 to the third definitely equals 125. So now, looking at letter B, just like in letter A, we're going to have to rewrite this so that they have the same bases, but the thing here is this: 8 is not a power of 4, and 4 is not a power of 8. But I recognize that both of these are powers of 2. So what I end up with is a situation where I'd say, well, 8 is really 2 cubed, and so I'm going to write 8, which is 2 cubed, to the x plus 2. And I'm going to write this here as 2 squared on the inside to the x minus 3. And so the nice thing is, because we have our properties of exponents that say, look, when you take a power to a power, you multiply your exponents, we really get 2 to the 3 times x plus 2, equaling 2 to the 2 times x minus 3. And so it is very true that these things are equal here. That's a 3. So we get 3x plus 2 equals 2x minus 3. So let's go ahead and simplify both sides here. I suppose we'd get 3x plus 6 on the left and 2x minus 6 on the right. If we were to subtract 2x over to the left side here, we'd end up with just 1x on the left. So x plus 6 equals negative 6. So if we were to subtract 6 from this, we would determine that x is equal to negative 12. And again, this is something that we can go plug back in and check to see that we actually get the correct answer here. But that's how we solve exponential equations. If possible, let's use the one-to-one property. In the next video, we'll look at when we can't use one-to-one, what do we rely upon next. Cheers.